we want to push forward and see if we can actually graphically draw a production function. Remember, firms exist to produce and sell. Okay? They produce products or services, and they sell it to people who are willing to voluntarily pass green sheets of paper to get that. Today we want to look at a little bit how that function might look. We said that the production function is quantity is equal to a function of labor and capital. And I've used a semicolon here instead of a regular colon to represent that capital is parametric right now. This is fixed in the short run. And indeed, just to remind you, we are in the short run here. Okay? That's what we're dealing with. So the capital that this firm has to work with is fixed. This is always variable in the short run. So the labor is variable, the capital is fixed. For example, the craft plant, they've got a fixed brick and mortar. In that fixed brick and mortar, they've got fixed assembly lines. They got processes there to make jars of mayonnaise. Workers come in. A lot of other variable inputs come in. Eggs, glass jars, paper labels, things like that it's going to all be part of the finished product, which is a jar of mayonnaise. We're all going to lump them into this one convenient category called labor. So labor is kind of a proxy for us, not just the worker's time, but also the materials the worker combines to make the product. I want to think about what this looks like, and so what I'm going to do is I'm going to think about constructing a curve that has inputs on the horizontal axis and output, lowercase q, the output for that firm, on the vertical axis. Now, for us, inputs is just L. L is the only thing we can change in the short run. Capital is fixed. So I'm going to draw a curve here that looks like this production function, but to make it a little bit easier to understand, I'm going to go to a new page on my screen. We have on this vertical axis output, and on the horizontal axis we have inputs, which in this case is labor. And I'm going to put here, just so you remember, that's the inputs. The production function looks something like this. Production function is Q, and it's a function of L for some fixed level of capital. Our capital is fixed because we're in the short run, and we'll say it's equal. Capital is equal to some K0. We don't even need to put it in the equation. We'll suppress it because it's a constant now, and we're just worried about varying labor. Now, along this curve, you'll notice that there's some region where, as we increase our inputs, output is going up at a faster rate. Notice how that curve is getting steeper? The curve output's going up, but it's going up at a faster rate. And then when we get past this point that you will learn in a math class is called an inflection point, past that point, what's happening to this curve? Well, it's still going up, but it's going up at a slower rate. This curve is flattening out. The slope is falling for this curve, okay? And this particular region where the slope is flattening out, we have a name for this in economics, okay? And that is, this is the law of diminishing marginal product. Some people say diminishing marginal returns. That works too. We're going to use diminishing marginal product. Well, let's think what this says. Diminishing marginal product. What is marginal? Well, throughout any economics course that you would take, economists use the word marginal when they talk about a change, okay? The change in product, okay? Diminishing change in production or output or returns. So if you were to talk about, what you might have in a calculus class as a derivative, a change in something, economists put the word marginal in front of that. If you're going to take a derivative of some curve, like a production function, that would be the marginal product. The slope of the production function is the marginal product. The slope of the production function is the marginal product. And what the law of diminishing marginal product says is that that slope is going to eventually start getting smaller. That is exactly this region. As you continue in this region to increment out inputs, more and more labor, if you just keep increasing labor by 1 unit, 1 unit, 1 unit, 1 unit, well, you're going to get more jars of mayonnaise, but the extra jar of mayonnaise for the extra worker is getting smaller than it was for the previous worker. Now, is this because the extra worker is just not very good? No, it's because you're using these workers, this labor, too intensively with the fixed capital. As the engineer would say, well, there's an optimal amount of labor you should put with that amount of capital. You say, well, I understand that, but I do need to get a few extra cases of mayonnaise out this week, so I'm going to put some more workers in there. They might not have as big a contribution as the previous workers, but they're still going to make more jars of mayonnaise. Let's think about why this happens. Here, this part of the was a region where there's actually increasing marginal returns. It's quite common in a production function. Think about if you were building cars on an assembly line. If you were building cars on an assembly line, you got this shell of a car coming down the assembly line. If you only got one worker, that worker's got to work on one side, and then she's got to jump to the other side and work on that side. And then she's got to jump back to the passenger side and work. Then she's got to jump back to the driver's side and work. They're putting car front quarter panels on, tires, all of these sorts of things. If we had just two workers, the workers could remain on one on the passenger side and one on the driver's side of that assembly line and get a lot more work done. In fact, if we had 4 workers, they'd even be bigger. This is, on this picture, this is like what's happening down in this region. Just adding a few workers at low level of labor into that factory, just adding a few workers can really ramp up production. However, when you get to some point, adding extra workers is not going to have that anymore. Basically, labor is being used too intensively at that point in time. This curve is going to start flattening out. In fact, you could imagine, if you think about that craft plant on the edge of town, suppose I told you that craft plant's got 100,000 square feet. Well, you could put a lot of workers in there, but eventually, in the short run, I mean, nobody would be silly enough to do this, but you could imagine continuing to increase the number of workers out here, see what happens, and you could see what actually happened in that situation is that this curve would actually start to come down. A bad thing. Your extra workers would actually diminish output. How's that work? Well, just imagine cramming all these workers together. There's no room to move. You're knocking over cases. Glass jars are falling out. It's a sort of a silly example, but it works. I mean, if you have a fixed capital and you try to put more and more workers in there, eventually they're going to be less productive than they would if they just didn't have that many people in there. So, no manager is going to want to get out in this region. Okay, so we'll just say that region. Nobody's going to go that far. Finally, one last thing I need to talk to you about, and that's this part right here. So economists use the word law very sparingly. When we use law, we think that basically this means we really don't know of any counterexamples. That, in other words, it doesn't matter what you're doing, whether you're digging ditches, or whether you're trimming trees, or you're making Chevrolets, or Boeing 737s. Every production process is subject to the law of diminishing marginal product. Every production process has this in place. Now what that means is I can actually draw you an axis system where I've got output of this firm, and on this axis I got inputs, and I know that the fully general production function is one that looks like this. It's going to have that increasing returns range at the very beginning, but it's very inevitably going to hit that inflection point, and then it's going to get to that point where, in fact, as you continue to add inputs, output is going to go up, but it's going up at a decreasing rate. That's the law of diminishing marginal product. You can see that that curve is flattening out. That's very important to us. This is going to help us understand why supply curves slope up. Think about the intuition. We already did supply curves. We understood that in order to get firms to put more output on the market, you had to offer them a higher price. This is really explaining that if you think about it. It's saying that if you want to keep getting more output out, the extra output is going to be, it's more expensive, because for hiring an extra worker, I don't get as many extra jars of mayonnaise. So those extra jar of mayonnaise I'm going to have to hire 2 extra workers to get the extra jar of mayonnaise instead of just 1 to get it. So if you want me to put more out, you're going to have to pay me more money. That's why the supply curve has that upward slope, and we're going to get to that when we think about building our cost curves. But the point I want to get across to you is that this function, it's a fair thing for you to sit and look at this screen and say, you know what, this guy's telling me that this is a function that describes making 747s with the same accuracy as it describes trimming trees or book binding or distilling gas. And the answer is yeah, I do. I really mean that, because I know, because of that famous word law. I don't know of any industry yet that has beaten technology in this. I don't know of any industry that's beaten nature and has somehow been able to get around the law of diminishing marginal product. And because of that, every firm is going to get to that point where as they increase their inputs, the marginal return from that extra input is not as high as it was from the previous input. That means it's going to get costlier and costlier to produce that product.